Have you ever wondered why water has a bent shape but carbon dioxide is linear? Well, hello everyone and welcome to our video on valence shell electron pair repulsion theory, or VSEPR for short. This video will explain how VSEPR helps identify molecular shapes while explaining their importance and the role of electron repulsion forces. Let's get started. Electron domains. These are regions where electrons are found around the central atom. They can be bonding pairs, which are shared electrons in a bond, or lone pairs, which are non-bonding electrons. Bonding pairs versus lone pairs. Bonding pairs form connections between atoms, while lone pairs don't participate in bonding but still affect molecular shape. Bond angles. They are angles between atoms and a molecule determined by repulsion forces. Molecular shapes. It is the 3D arrangement of atoms around a central atom, influenced by the number of bonding and lone pairs. Now, let's go through different molecular geometries and see how VSEPR determines their shapes. As you can see in my drawing, you see that the linear geometry has 2 bonding pairs, 0 lone pairs, and the bond angles are 180 degrees. An example is CO2. In my next drawing, you see the molecular geometry, the trigonal planar. It has 3 bonding pairs, 0 lone pairs. The bond angles are 120 degrees. An example is BF3. A bent trigonal planar have 2 bonding pairs, 1 lone pair, and bond angles that are less than 120 degrees. An example is SO2. Has 4 bonding pairs, 0 lone pairs. Bond angles are 109.5 degrees. An example is CH4. Trigonal pyramidal, 3 bonding pairs, 1 lone pair. The bond angles are less than 109.5 degrees. An example is NH3. Draw 2 bonding pairs, 2 lone pairs, angles that are less than 109.5 degrees. An example is H2O. Trigonal bipyramidal, 5 bonding pairs, 0 lone pairs, angles that are 90 degrees and 120 degrees. An example is PCI5. Octahedral, 6 bonding pairs, 0 lone pairs. The bond angles are 90 degrees. An example is SF6. When we talk about water, which stands as H2O, water has 2 bonding pairs and 2 lone pairs. According to VSEPR, lone pairs push bonded atoms closer together, making the shape bent instead of linear. The bond angle is about 104.5 degrees. This bent shape is why water is polar. To summarize what was said in my video, VSEPR theory helps us predict molecular shapes by considering electron repulsion. The more lone pairs, the more they push bonds closer together, altering the shape. Molecular geometry affects polarity, reactivity, and properties of substances. So next time you see a chemical formula, try to predict its shape by using VSEPR. Thank you.